Welcome to the video solution of your selected question from the Mathematics the Easy Way DVD. If you have not yet seen the introduction video on the DVD, please do so now, as it outlines how the Easy Way series will help students to be successful in their CXC exam. While the Easy Way video solutions will help to cement the understanding of certain special questions, the solution books are still absolutely necessary as they cover all the various types of questions that are set in CXC exams. Welcome to question 9A of the CSEC Math June 2012 video solution. And in question 9A part 1, we are given a pair of simultaneous equations to solve. Now this first equation is a linear equation, while this second equation is a nonlinear equation, or it's the equation of a curve. And typically, when we have simultaneous equations where one is a line and the other is a curve, it is better to use the method of substitution, where we tend to substitute the equation of the line into the equation of a curve. And because this linear equation is expressed with y as a subject, we can go ahead and substitute for the y in this curve equation. So let's show that process. First, we're going to refer to the linear equation as equation 1 and the equation of a curve here as equation 2. And as I said, what we're going to do, we're going to substitute for y equation 1 into equation 2. So what it means, we are simply replacing this y with 8 minus x, because y is equal to 8 minus x in equation 1. So let's go ahead and show that process. So this second equation becomes 2x squared from here plus x, and the y here is replaced with the y from this equation, which is 8 minus x, and that's it, equals the negative 16 from here. And here now we have formed an equation where the only unknown variable is x, and this equation will be reduced to a quadratic equation, and we can go ahead and go through the process. Now when we expand, we end up with 2x squared plus x multiplied by 8 is 8x, and x multiplied by negative x here is negative x squared, and we have this side. And so we now have 2x squared minus x squared, and we can show that is x squared. This 8x comes back here, and then the negative 16 comes on this side to become positive 16. And this is now a quadratic equation we have to solve. And we can solve this quadratic equation by factorization. And so let's go through the process of how we would factorize this expression. And this is it. We are factorizing x squared plus 8x plus 16. Now the aim of factorization is to split this middle term 8x into two terms, so we can create 4 terms and use factorization by parts. And the process to determine how this 8x term in the middle of this quadratic expression can be split is quite straightforward, and let us go through that process. And this is it. We multiply the coefficient of x squared with a constant term here, that's 1 multiplied by 16, and that is 16. And then we want factors of this 16 that add to the middle term 8, and we can show that we want factors of 16 that add to 8, and that's it. We are looking for factors of 16 that add to 8, and the factors of 16 that add to 8 are 4 and 4. 4 multiplied by 4 is 16, so 4 and 4 are factors of 16, and 4 plus 4 is 8. So 4 and 4 are factors of 16 that add to 8, and therefore we can split this 8x into 4x plus 4x. So let's go ahead and show that here. And this is it. X squared comes back here. The 8x is split into 4x and 4x. That's it. And we have plus 16 comes back here. So now we have 4 terms, and we can factorize by parts. So we look for a common factor in the first 2 terms, and then we look for a common factor in the second 2 terms, and go through the process of factorizing by parts. And this is it. The common factor in the first 2 terms is x, and when we factorize x from these 2 terms, we end up with x multiplied by x plus 4, and on this side the common factor from these 2 terms is 4, and so we end up with 4 into x plus 4. And then inside the bracket here we have x plus 4 on this side and x plus 4 here, and so x plus 4 is a common factor between this term here and this term here, and so we can use this x plus 4 as a common factor for the next line, and this is it. We end up with x plus 4 multiplied by x from this side plus 4 from this side, and so we have x plus 4 multiplied by x plus 4, and that is x plus 4 squared equals 0. So let's continue on the next page. So this is what we have, x plus 4 squared equals 0, and if x plus 4 squared is 0, it means that x plus 4 must be 0, and we can show that. That's it, x plus 4 equals 0, and if x plus 4 is 0, then x is equal to negative 4. So there's only one x value where this line intersects this curve, only one point of intersection, and we have to now find the corresponding y value to go with this x value, and we can simply substitute this x value into the equation of the line to find that corresponding y value. So let's go ahead and show that, and this is it. We are substituting x equals negative 4 into equation 1, that's here, and that is done simply by replacing x here with negative 4. So let's show that. So y is equal to 8 from here minus, and then the x value that we are substituting is negative 4. So this really is 8 minus a negative 4. That is the same as 8 plus 4, and 8 plus 4 is 12. And so our solution for these simultaneous equations is x equals negative 4, y equals 12, and that is one point of intersection between the line and the curve. Only one point of intersection. The point is negative 4, 12. Now let's move down to part 2. Now part 2 is asking us to state whether or not the line 1 is a tangent to the curve 2. That is, if this line is a tangent to the curve. So let's look at that on the next page. That's it. Is the line a tangent to the curve? So let's discuss the intersection of a line and a curve, and we are looking at quadratic cases where there is no more than 2 points of intersection. Now there are 3 possibilities for the intersection of a line and a curve. First, you may have 2 points of intersection as shown here. This is a curve, that's a line, and there are 2 points of intersection. And when you substitute the equation of a line into the equation of a curve, you're going to end up with a quadratic equation that has 2 roots. When there are 2 roots, it means that there are 2 points of intersection, and this is what you will end up with if there are 2 points of intersection. The next possibility is 1 point of intersection, and if there's 1 point of intersection, it means that when you substitute the equation of a line into the equation of a curve, you end up with a quadratic equation that has only 1 root, or it has equal or repeated root, but it comes out as 1 root, right? And in that case, the line is a tangent to the curve as shown here. When the line is a tangent to the curve, the quadratic equation that you end up with will have only 1 root, 1 point of intersection. The third possibility is when there is no intersection as shown here. This is the curve, this is the line, there is no intersection. And when you substitute the equation of a line into the equation of a curve, you end up with a quadratic equation that has no roots, no point of intersection with the x-axis. Okay, so that's your possibility. So based on our result from the simultaneous equations, because we have 1 point of intersection, means that the line touches, that is, it's a tangent to the curve. The line touches the curve at only 1 point. That point was negative 412 from our solution, and therefore the line is a tangent to the curve. And so that's the answer for question 9a. Let's move down now to question 9b. Now in this question we are told that a florist makes bouquets using X roses and Y orchids. That is, the number of roses used is X and the number of orchids used is Y. And the bouquets are made under the following conditions. 1. The number of orchids must be at least half the number of roses. 2. At least 2 roses must be used. And 3. No more than 12 flowers can be used. And we're required in part 1 of this question to write 3 inequalities to represent these conditions. Now let's look at the conditions one at a time. The first one is saying that the number of orchids, which is Y, must be at least half the number of roses, which is X. At least half the number of roses means equal to or greater than half the number of roses. So let's show the first inequality. And this is it. Y, which is a number of orchids, must be at least means equal to or more than half the number of roses, which is X. So this inequality represents the first condition. The second condition is telling us that there must be at least 2 roses in each bouquet. At least 2 roses means that the number of roses must be 2 or more. And let's show the inequality for that. And this is it. The number of roses, which is X roses, the number of roses, which is X, must be greater than or equal to 2. At least 2 means 2 or more. So this is the inequality for the second condition. The third condition is saying that no more than 12 flowers can be used. In other words, there must be no more than 12 flowers. Now the word flowers here is taken to mean the sum of the roses and the orchids together. And so the total of the roses and the orchids must be no more than 12. Can be 12 or less, but not more than 12. So X, which is number of roses, plus Y, which is number of orchids, can be 12 or less. So let's write the inequality to represent the third condition. And this is it. The number of flowers, which is X plus Y, that is the roses plus the orchids, can be no more than 12. It can be equal to 12 or less, but not more than 12. And so this is the inequality that represents the third condition. And that's it. That's the answer for part 1. The 3 inequalities representing these 3 conditions. So let's move down now to part 2 of this question. Now in part 2, we are given this graph of the lines associated with the 3 inequalities. Now let's talk about these lines a bit. For this first inequality, y greater than or equal to half x, the line that is associated with this inequality is this line, y equals half x. And the line that is associated with this second inequality is this line, x equals 2. And the line that is associated with the inequality x plus y less than or equal to 12 is this line, x plus y equals 12. Now, this first inequality is saying y is greater than or equal to half x. The equal means that the line is a part of the inequality, and the greater than sign means that we want the region above the line. And so we want the line and we want the region above the line. This second inequality, where we have x greater than or equal to 2, the equal means that we want the line to be a part of the inequality, and the greater than means that we want values of x that are greater than 2. So it means that we want to the right of this vertical line x equals 2. In this case, where we have x plus y less than or equal to 12, the equal means that we want the line x plus y equals 12 to be a part of the inequality, and we also want the region that is below the line where x plus y is less than 12. So we want the line x plus y equals 12, and we want below the line. The lines are drawn unbroken because the lines are required to be a part of the inequality in each of the cases. And in this case, we want below this line. In this case, we want above this line, and in this case we want above this line, and therefore the common region is inside this triangle here. This triangle here satisfies the three inequalities. It is this line and above, it is this line and above, and it is this line and below. And so the region here in this triangle satisfies the three inequalities. So let's now answer the questions. Part 2 wants us to shade the region which represents the solution of the three inequalities. In other words, shade the region that satisfies the three inequalities, or shade the common region. And as we have explained, the common region is inside this triangle here. So let's go ahead and shade that region that satisfies the three inequalities. Alright, so let's move down now to part 3. Now part 3 is telling us to write the coordinates of the vertices of the region which satisfy the three inequalities. In other words, we have to write down the coordinates of the vertices of the shaded region. That's here, here, and here. So let's go ahead and label those vertices and then write down the coordinates. So these are the three vertices of this common region. A is the point 210, B is the point 84, and C is the point 21. So we can go ahead and write those three coordinates. A is the point 210, B is 84, and C is 21. So that's the answer for part 3. Let's move down now and answer part 4. Now, in part 4, we are told that bouquets are sold for profit, such that there's a profit of $3 on each rose and $4 on each orchid. Now remember that there are X roses and there are Y orchids, and so we can write an expression for the total profit. $3 on each rose, $4 on each orchid means that our profit P can be expressed as P equals 3x plus 4y. $3 on each x, so that's 3x, plus $4 on each y, so that's 4y. So our profit is given by this expression, P equals 3x plus 4y. And this question wants us to calculate the maximum profit. Now the maximum profit will occur at one of the vertices of this common region which satisfies the three inequalities. If a vertex cannot be used, then we would normally go along the side. But in this case, each of the vertices can be used to find profit. And so, to calculate the maximum profit, we have to analyze which of the vertices would give us the maximum profit. There is no need to analyze the vertex C because clearly there's a small number of roses and orchids that are used at vertex C. And so the maximum profit will occur at either point A or point B, because where A has a higher Y value than B, B has a higher X value than A. And so we have to analyze the profit at A and the profit at B and compare those two profits to determine the maximum profit. Let's show that calculation. And this is it. The maximum profit will occur at vertex A, which is the point 210, or at vertex B, which is the point 84. And all we have to do is use this profit function, this profit equation, to calculate the profit at A and the profit at B, and then we'll see which of the two will give us the maximum profit. So let's show that calculation. And this is it. The profit at A will be given by 3 multiplied by 2 plus 4 multiplied by 10. That is using this function. The profit at A will be 3 times the x value at A, which is 2, plus 4 times the y value at A, which is 10. And this calculation works out to be 46. And if we look at B, the profit at B will be equal to 3 multiplied by the x value at B, which is 8, plus 4 multiplied by the y value at B, which is 4. And this is it. The profit at B is 3 multiplied by 8 plus 4 multiplied by 4, and that works out to be 40. So clearly we're having our maximum profit at the point A, and we can go ahead and mark that. And since we have found our maximum profit at A, which is 46, we can write our solution line, and this is it. The maximum profit is $46 when 2 roses and 10 orchids are sold, because at the point A we're having 2 roses and 10 orchids. That's it. Our maximum profit is $46 from here when 2 roses and 10 orchids are sold. That's the answer for this question, and we'll do our next question, question 10, in our next video. See you then. You have just seen the video solution for a special CXC question, but this is only one of the many different ways that these questions are written. All mathematical principles can only be fully understood by solving many questions, and so I always tell my students, more maths equals better maths, and if they study hard, they will pass easily. All the various types of CXC questions are covered in the Easy Way Mathematics Solution book, and you need to practice every single one of them. Other books in the series are the Easy Way Multiple Choice Specimen book, the Easy Way Unit 1 Cape Mathematics Solution book, and the Easy Way Account Solution book. Please feel free to contact me with your comments and queries at any time.